Let's take a look at Lewis structures. This is Dr. B. These are also known as electron dot structures, and they are a really quick way to get a look at an atom and determine how reactive it might be. They're also a nice way to group atoms together to form covalent bonds. Here's an example right here. This is the Lewis dot structure for oxygen. I see 6 electrons around it, and I see 2 lone pairs and 2 bonding electrons. This tells me that oxygen would tend to form 2 bonds. How did I know that? Well, all we do for Lewis dot structures is draw 2 electrons around each side of the atom symbol in a square, and it tells you a lot. Here it is for most of the periodic table. The first column, that is the alkali metals, only have 1 valence electron, hence 1 dot. Group 2, 2 dots. Group 3, I'm going to call it, not group 13. 3 dots, don't forget to spread them out. You may recall this is known as applying Hund's rule. 3 bonds typical for these guys. 4 bonds typical for these, but why not 5 bonds for nitrogen? Because we can only have 8 valence electrons, 2 per orbital, somebody's got to pair up. Or apply this just Lewis box rule kind of thing. Draw 2 electrons around each side and pair up when you need to. Therefore, oxygen with its 6 valence electrons will form 2 bonds, fluorine 1, and this also shows why the noble gases are completely, well, just about completely unreacted. So hydrogen, oxygen, those are the Lewis dot structures, and they can bond together. Oxygen needs 2 more electrons. He can get 1 from each hydrogen. But hydrogen would prefer to have 2 electrons to become isoelectron with neon. That's unique for the first column. And therefore, when they bond together, they can form a molecule of water. Note that when it does so, oxygen now has, by sharing, its 8 valence electrons. Hydrogen has its 2 valence electrons. A lot of nice information there. That right there is the covalent bond formed for water, and 2 dots defines a covalent bond, so you could also just replace it with a line. It's a lot quicker. Double bonds can form. Imagine carbon dioxide. Carbon had its 4 valence electrons, but by sharing them with oxygen, we arrive with a situation where you can draw it with the lines if you prefer, where full octets are available for each of the 3 atoms. Oxygen has its 8, do you see it? Carbon has its 8, the other oxygen has its 8. Beautiful. We can even do this for triple bonds. Consider nitrogen with its 5 valence electrons. Bond, bond, bond. Maybe you could imagine better if you threw one on top of it and then each of these single electrons pair up to form bonds. However you do it, you should be able to see that nitrogen has its full valence shell for each of the nitrogen atoms and contains that very strong triple bond. This is a look at Lewis structures.